For the atoms and periodic table review, let's go ahead and do the answers for that. So number one, this first section you're going to label using either proton, neutron, or electron, or a combination. Some of these answers might have, or some of these questions might have, require you to choose two letters, for example, like this one here and that one there. So it has a charge of +1, so that's going to be your proton. Protons have a positive charge, so that's going to be A, proton. No charge is B, neutron. A negative charge is C, electron. 4, mass number minus atomic number, or that would be the same thing as saying mass minus protons. That's how you find the neutrons, or B. Identifies the element, that gives it its atomic number. Each element has a unique atomic number, that's going to be the proton. Changes in an isotope. So that's going to be B, the neutron. So remember, an isotope, isotopes are atoms of the same element, but they have different mass numbers. So that means that they have the same number of protons, but they have different numbers of neutrons. So the neutrons can change. Number 7, an energy level / electron cloud, that's the electron. The electrons are in the energy levels. Number 8, what is in the nucleus? That is the proton and the neutron. Always equals the atomic number, so that's going to be the proton. Remember, the electron does equal the atomic number, but that's not always. Remember, that's just for now. So that would be proton. Number 10, equal in a neutral atom. Positive equals negative. So that's going to be the proton and the electron. Has no mass. So that's going to be the electron. Remember, the mass number is protons plus neutrons. So in nowhere in that equation do we find the electrons. The electrons are so small that we don't count their mass. And number 12, always stays the same in an isotope. That's going to be the proton. Remember, we said that in an isotope, they have to be the same element, which means they have the same number of protons, but the neutrons are different. So 12 is A, proton. 13, what particles are in the nucleus? So once again, that's proton and neutron. Where is the majority of the mass located? That is the nucleus, because protons and neutrons make up the mass, and they are in the nucleus. How is the periodic table arranged? Well, the most important way is it's arranged by increasing atomic number. The other two ways that it's arranged are the rows are organized by, they go left to right, and they're organized by energy levels. Remember that rows are also called periods. And then you have your columns, which go up and down, and they're organized by valence electrons. And remember, those are called groups or families. How do you find mass number? That's going to be protons plus neutrons. You could also say atomic number plus neutrons, but it's actually the most correct to say protons plus neutrons. How do you find the number of neutrons? Well, we need to start with the mass number and subtract the protons. And again, you could say atomic number, but it would be most correct to say protons. What is another name for the columns up and down? Well, that would be group. And a row is a period. Where are electrons located? That would be in the energy levels or the electron cloud. or you could say outside the nucleus. Why are the noble gases different? They have full outer shells. Their outer energy level is full, meaning they have the most valence electrons that they can have. It makes them very stable, and it makes them unreactive. Give the group number for noble gases. That would be group 18. They're all the way on the far right. The alkali metals are group 1. The alkaline earth metals are group 2. And the halogens are group 17. So you don't have to memorize these. These should be labeled on your periodic table. Name the element in group 2, period 5. So let me open up my periodic table here. Group 2, period 5. Okay, group 2, period 5. 1, 2, 3, 4. Okay, that's going to be strontium. Group 2, period 5. Okay, strontium, Sr. Group 14, period 3. Group 14, period 3. Okay. That's going to be silicon. Group 14, period 3. Yep, silicon, Si. Group 17, period 2. Group 17, period 2. That's going to be fluorine. Fluorine, or F. Okay, name the noble gas in period 1. That's helium. Okay, that's the first element in the noble gas group. Alkali metal in period 5. So alkali metal, that's group 1, and you just count down 5. So 1, 2, 3, 4, 5. That's going to be rubidium, Rb. And the halogen, period 3. So that's group 17, and count down to period 3. That's going to be chlorine. Chlorine in period 3. So you can highlight just period 3, and chlorine is a halogen in period 3. Valence electrons are the electrons in the outermost energy level. Elements in the same group have the same number of valence electrons. Elements in the same period have the same number of energy levels. I can guarantee you that's going to be a multiple choice question. Which elements are most similar to lithium because they have the same number of valence electrons? Well, we just said that valence electrons are relative to group number. So elements in the same group have the same number of valence electrons. So if we're looking at lithium and we want to find elements that have the same number of valence electrons, we're going to have to find elements that are in the same group as lithium. So let's find lithium on the periodic table. Lithium here is in group 1. So elements that are in group 1 or other alkali metals are going to be the most similar to lithium. They're all going to have one valence electron. So group 1 or alkali metals. So elements like sodium and potassium. 28. Why do neutral atoms have no electric charge? That's because the positive protons cancel the negative electrons. They're equal, so they cancel. How many protons, neutrons, and electrons does oxygen-16 have? Look up oxygen on your periodic table. Oxygen here has an atomic number of 8. So that means that the protons are 8, and the electrons are 8, and the neutrons we have to subtract. We do 16 minus 8, and that is also 8. Isotopes exist when there's a different number of neutrons. The different number of neutrons makes it have different mass numbers. How many neutrons does the isotope phosphorus 33 contain and phosphorus 32? Well, first we have to figure out the atomic number for phosphorus. So phosphorus has an atomic number of 15. So that means it has 15 protons. So then we would do 33 minus 15. That's going to be 18. So that one has 18 neutrons. And 32 minus 15 is going to be 17 neutrons. Fill in the missing info. Silicon. Let's look up the atomic number for silicon. Atomic number is 14. Oops. So that's going to be protons and electrons. We're going to assume that all of these atoms are neutral. So the mass number is the protons plus the neutrons. So we're going to do 14 plus 14, and that is 28. For the second element, they didn't give us the name or the symbol, but we know it has 16 protons and 12 neutrons. If it has 16 protons, it's going to have 16 electrons. We need to figure out what element it is. So 16 protons, atomic number 16, that is sulfur. So sulfur has an atomic number of 16. So fill that in. And then for the mass number, again, remember protons plus neutrons. So 16 plus 12 is 28. Right? Right. Okay, calcium, mass is 40. Electrons are 18. Uh-oh. For it to be neutral, it needs 20 electrons, because if we look up atomic number for calcium, calcium has an atomic number of 20. So that's my mistake there. Remember I said electrons are the same for now. That's a little foreshadowing for when they're going to be changing. So that's my bad. But you can leave it at 18 if you'd like, or you can make it 20. We'll talk about it later. If the mass is 40 and the protons are 20, we need to find the neutrons by doing the mass minus the proton. So that's going to be 20. 40 minus 20 is 20. What is the name of the element with 26 protons? Well, let's find out. Let's look up 26 on the periodic table. That is iron. Iron. What is the name of the element with 17 protons? It's going to be chlorine, but let's double check. Chlorine, 17 protons. Guys, notice how much I am using the periodic table. Okay, you should be using your periodic table just as much as I am. You don't have to have all this stuff memorized. It's all about using that resource. Complete the following information and draw the Bohr model in the chemist shorthand for sodium. Mass is 23, so there's that information. The symbol for sodium, remember, is Na. If we look it up on the periodic table, we're going to find that sodium has a an atomic number of 11. So atomic number of 11 means that we have 11 protons. We're going to have 11 electrons because we're going to assume that it's neutral. If the mass is 23, we can find the neutrons by doing the mass number minus protons. So 23 minus 11 is 12. Let's go ahead and do the Bohr model. I'm going to zoom in on this. Remember the Bohr model, you are placing electrons in these rings here, these energy levels. So there are 11 electrons that we need to draw, but we can go ahead and fill in the protons and neutrons here as well. So 11 protons, 12 neutrons. And again, we're drawing 11 electrons here. Skip the very first ring because that's representing the nucleus. So we're going to put dots here. Remember, the first energy level can only contain 2 electrons, then it's full, and we have to move to the next one, which can hold up to 8. So let's go ahead and draw 8 here in the second ring. And the the second ring is now full because it can have up to 8 electrons. So far we have drawn 10 electrons. We have 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, we need to draw 11 because it has 11 protons and 11 electrons. And remember, we're drawing electrons. So we need one more in the third energy level. So now our Bohr model is complete. Remember, in that third energy level, we can draw up to 8 electrons. But we only need to draw 1 there. The configuration, that's going to be how many electrons are actually in each ring. So we've got 2, 8, and 1. The shorthand, remember, that's the symbol, and then the mass number over the atomic number. Valence electrons, that's the electrons in the outer energy level right here. So it's only got 1 valence electron. We have 3. We used 3 energy levels, so that means it's in period 3. It has 1 valence electron, so it's in group 1. If you look that up on your periodic table, it is an alkali metal. Group 1 is alkali metals, and the isotope name is sodium 23. Remember, the isotope name is the element name and then the mass number. What information can be gained by looking at an element's period? You can figure out how many energy levels it has. And what can be gained by looking at an element's group? You can figure out how many valence electrons it has. What is the charge of the nucleus of an atom? Remember that the nucleus contains protons and neutrons. Now, neutrons don't have a charge, so they're not going to contribute to the charge of the nucleus. The protons are positive, and they're the only particle that's in the nucleus that has a charge, so the nucleus itself is also going to be positive. But the overall charge of the atom, we've got protons, neutrons, and electrons. And remember, we've talked about how protons and electrons are going to be the same. So they're going to cancel each other out. And the neutrons, they don't have a charge, so we don't have to worry about them. So the overall charge of an atom is going to be neutral or 0. Okay. What is the correct number of protons, neutrons, and electrons for atom B? So we're going to look at atom B first. It says the atomic number is 8 and the mass is 18. So protons are going to be the same as the atomic number, which is 8. And so are the electrons. The neutrons, we're going to do the mass minus the protons. So 18 minus 8 is 10. Compare atoms A and B. Are they isotopes or different elements, and why? Atoms A and B. So A and B. So if we look at the atomic number, we can see they have the same atomic number. So that's a good start. And if we look at the mass, the masses are different. So A and B are isotopes. Okay, and that's because they are the same element with different masses. Compare atoms B and C. Are they isotopes or different elements, and why? So B and C, start by looking at the atomic number. The atomic number is not the same. So they're not even the same element. So that means that they cannot be isotopes. They are different elements. And that's because they have different atomic numbers. True or false? We can assume atom B is neutral because the number of electrons is the same as the number of protons for now, and that is true. Make that a little bit neater. There we go. We're going to call that true. I'm going to add one more question here, and we'll see how we do. So the question I'm going to add is, how many electrons could be added to the outer energy level of a nitrogen atom? Now this is next level thinking, because you have to think about how many electrons does nitrogen have. Nitrogen has an atomic number of 7. So it has 7 protons and it's going to have 7 electrons. Okay, 7 protons. And we're going to draw some energy levels. Whoa, that was not a circle. Okay, so there, change color here for my electrons. Remember, the first electron can have 2, or the first energy level can have 2 electrons, and we need 7 total, so that means we need 5 more. Okay, let's think about how many electrons can fit in this energy level. Okay, remember this is the second energy level, so the second energy level can hold up to 8 electrons. So how many more could fit in this energy level? Well, we could fit 3 more. It has 5, so we could fit 3 more electrons in that energy level. So the answer would be 3. Okay, so that's some next level thinking, and that's going to give you a little bit of foreshadowing about what's coming up in our next unit. We're going to do a lot of thinking like that. Okay, so that's it.